Good morning, all of you. Today, I, Moumita Ghosh, currently working as Assistant Professor in the Department of Information Technology of Haldia Institute of Technology, going to discuss on cluster analysis. Now, first of all, we have to know what is cluster analysis. The process of grouping a set of physical and abstract objects into a classes of similar object is called the clustering. That means within one cluster, the objects are more similar. Similarity in terms of some criteria, and this is essentially called as a feature. As that's why it is written, the cluster is a collection of data objects that are similar to one another within the same cluster and are dissimilar to the object in the other cluster. In machine learning, clustering is an example of unsupervised learning. As unlike the classification is an example of supervised learning, which relies on predefined classes and class level training. Example, clustering does not rely on predefined classes or class level. So next, so from this example, we can see that clustering is a form of learning by observation rather than learning by example, which is actually done in the classification technique, where we used to do learning by example. See here in the diagram that there are four clusters. This is shown in the red, green, purple, and the blue color. And some geometrical notations are there. These are the center of the classes, or center of the cluster. Now, what is the significance of this center? That means from the center, we have to measure the distance of each data point. And the data points which are the nearest to the particular center is belong to that particular cluster. Now, the clustering is a very active theme of research focus on scalability of clustering method. Next, these are some requirement of clusterings in data mining. Now, this is a very important, then this is the points. So scalability, ability to deal with different types of attributes, discovery of clusters, minimal requirements of domain knowledge, ability to deal with noisy data, incremental clustering is also available, high dimensionality, constraint based clusterings, and interpretability and usability. There are typically 5 methods which belongs to a clustering technique, and the categories are partitioning based method, hierarchical method, density based method, and grid based clustering and model based clustering. Now these are the technique by which all the algorithms designed on clustering has been designed. Now today in our discussion we will mention the first method, which is the partitioning based method, and one example we will see, which is the K-means clustering. Now what is partitioning method? See, given a data set of n object or data tuples, which is called the data points, a partitioning method construct K partitioning. That means if I have 10 object, here 10 equals to n, and K partitioning means, suppose let assume I partition K equals to, I have assume K equals to 2. That means 2 cluster will be present for the 10 data points, where each partition represent a cluster and K less than equals to n. What does it mean? If the K equals to 1, that means all the 10 data points will belonging to the one particular cluster. That is, it classifies the data into K groups which together satisfy the following requirement. That there is 2 essential criteria are there. First of all, each group must contain at least one object. Without a single, if there is a no object, that means it is not assumed to be form a cluster. That means no data points should not be there in a single cluster. At least one object is required to form a cluster. Second one is that each object must belong to exactly one group. That means each object should have a one particular cluster. So So that's why it is written. Next, given K, the number of partitions to construct partitioning based method creates an initial partition. That means we have to assume the K, the value of the K. It then uses an iterative relocation technique. Generally, it is used the distance metric. I will come to that point later on. That attempts to improve partitioning by moving object to one group to another. That means, let's assume one data point. I'm giving the notation D1 is initially belonging to cluster C1. In the next iteration, it could have the possibility that the data object will be belonging to the C2 cluster. The general criteria of good partitioning is that objects in the same cluster are close or related to each other, whereas objects of the different clusters are far apart of the very different. Already I have discussed on this point. That means there is a high similarity between the object in a intra-cluster or data points of the intra-cluster, and the data points which are far apart, that means which belonging to the separate clusters, obviously they would have a very dissimilar criteria. So two important algorithms have been designed based on this method. This is the partitioning method. To achieve global optimality in partitioning method-based clustering would require exhaustive enumeration of all the possible partition. Instead, most application adopts heuristic methods such as K-means and K-medoid. Now, the K-means algorithm, where each cluster is represented by the mean or mean value of the object. That means whenever we consider the center, and the center is rely on the mean of the object value. Similarly, for the K-medoid algorithm, which will be discussed in the next class probably, each cluster is represented by one of the object located near the center of the cluster. Now, these two methods are the heuristic method. Now, see. We start with the K-means clustering. K-means clustering is an obviously unsupervised iterative clustering techniques. Why iterative? As we have earlier discussed, that iteratively we have to set the data points to a particular cluster. It partitions the given data set into K predefined distinct clusters. A cluster is defined as a collection of data points exhibiting certain similarity. It partitioned the data set such that each data point belonging to a cluster with the nearest mean. Now, why the mean is given? As we have seen in the earlier slide, that k-means depend on the mean value, or the k-means. In the case of k-means, the center is dependent on the mean value. Data points belonging to one cluster have high degree of similarity. Data points belonging to a different clusters have high degree of dissimilarity. Already we have quite known to these particular factors. Now see, these are the data points, all are belonging to a same, represented using a same color. That means these are all the data points. Now how many data points are present? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now before applying the K-means clusters, there are 18 data points altogether. Now, let us assume the K value equals to 3. Now, why the K value equals to 3? Because from the next example, we can see that I have to divide the whole 18 points into the 3 different clusters. That's why K is initially taken as or assumed as the 3. So after applying the K-means, we have seen the next figure where we can see that represented using 3 different colors, that 3 different clusters have been formed using the K-means algorithm. Now how these have been formed, that we will discuss using an example. But this is the main agenda, or this is the objective. The objective is that initially we have some data points, and after applying the K-means clustering, we will get some clusters. So raw data points will be transformed into some meaningful cluster. This is our objective, to apply K-means algorithm in clustering. Clear? Now next. This is the algorithm. What is the step 1? Obviously, we have to choose the number of cluster K. That means that means the value of the k we have to assume. Now step 2. Randomly select any k points as a cluster center. Initially k could be any value ranging from 1 to n. Select cluster center in such a way that they are further as possible from each other. Now initially we have to select the center from the data points, or we can select within the range of the data points also. Now what is the step 3? Calculate the distance between each data points and each cluster center. The distance may be calculated either by given distance functions or the Euclidean distance formula. If no distance formula is given, you can choose any distance formula. It could be Euclidean, it could be Manhattan, etc. Next, assign each data points to some clusters. A new data point is assigned to the cluster whose center is nearest to the data point. Step 5. Recompute the center of the newly formed cluster. Now, why we are recomputing? As I have told you, clustering is an iterative approach, or K-mean clustering follows an iterative approach. That's why recompute the center of newly formed clusters. Then the center of a cluster is computed by taking the mean of all data points contained in that cluster. Step 6. Keep repeating the procedure from step 3 to step 5 until any of the following stopping criteria is met. Center of newly formed cluster does not change. Data points remain present in the same cluster. That means after doing iteratively, no cluster centers have been not changing anymore, or data points are not changing its cluster. The maximum number of iteration has been reached. That means if anyone is said that you have to do up to iteration 100, then 100 iteration already we did. So no need to do any further calculation. Now, how to check the quality of each cluster? Now, this is the formula. We can assess the quality of clustering by adding up the variation within each cluster. Since K-means clustering cannot see the best clustering, it is the only option is to keep track of these clusters and their total variance and do the whole in this again and again different starting point. Now, this is for the variance, that this is the xi is the data point, minus this is the this is essentially the center of the cluster, and n is the number of data points. Now using this variance formula, we can choose variance formula. We can see that how much the data points are similar or dissimilar from one cluster to another cluster. The similarity index should be high within the intra-cluster, and the similarity index should be low within the inter-cluster of the data points. This is the formula to test the quality of the cluster. The way I have divided how much good, or how much how much good the clusters are, to know that this is the formula. Now this is one example, and this is another example. We will solve this example. Now see, this height and weight, these are the feature x and y. These two are two-dimensional feature. Now let us assume we will use the Euclidean distance. Now, step 1, we have to initialize to center of the cluster or to two cluster. Now, see, assume the center 1 is C1, which is we have taken that 185.72. This is the centroid, and for the cluster C2, the centroid is the 170 and 56. Now, how to calculate? Now, see from this. This is the distance formula, x minus a square plus y minus b square. Now, what is my center? First centroid is the 161. This is the first data point is the 185 square root over of plus 60 minus 72 square. Now, this is for the row 3. For the C2, we have calculated. The distance is the 4.48. Now, for the C1, the data point, the distance is 20.80, and for the C2, the data point is the 4.48. So obviously row 3 will go to the cluster C2 as the distance is lower than the distance of this. Similarly, we have to calculate all the data points, and finally we will get the final result. Now, what is the main drawback of the K-means clustering? The K-means algorithm is very much sensitive to outlier, as we are depending on the mean value. Suppose one is the sensitive to outlier, that means one is the beyond the range, so its mean value is calculated, which would be a lower. Instead of taking the mean value of the object in a cluster as a reference point, can we pick the actual object to represent the cluster using one representative object per cluster? Each remaining object is clustered with the representative object of which is the most similar. So that's why this is the main problem of the k-means, that it uses the mean value. So that's why another technique has been used, which is the k-medoid, which is the we have successfully uh, mitigate some of the drawbacks of the k-means clustering. Now, for the minimum, for the smaller data set, k-means is also works good. The partitioning method is then performed based on the principle of minimizing the sum of dissimilarity between the each object corresponding to the reference point. Now, that's all about the